Hello guys, welcome to my online physics class, key fact in physics. So what we do in this class is basically prepare our students that are about to write exams for WAEC, for NECO, for GCE, and even for JAMB. What we do is to pick up topics in physics and treat these topics, and at the end of the day, we pick out related questions in WAEC, in JAMB, and in NECO, and then we help students familiarize themselves with these questions. And also for students in SS1 and SS2 that don't really follow very well in class, that find physics very difficult, this is also a place where we teach it and make it easy to follow. In our last video, we introduced a topic, linear momentum and Newton's law of motion. We try to break down that very topic into subtopics that we'll be looking at in our various videos until the topic is over. And then we dive into questions in WAEC that we can encounter in this topic. So we treated linear momentum, the concept of linear momentum, and trying to familiarize students with what linear momentum is. But in this class, we'll be looking at impulse. Impulse is a subtopic in linear. So what is impulse? Impulse is simply the product of force and the time taken to bring about change in momentum. Impulse. Impulse is simply represented with the letter I. Is equal to force and time taken to bring about change in momentum. Please note the time taken to bring about change in momentum. So for impulse to have occurred, there must be a change in momentum. We defined momentum in our previous class as the product of mass and velocity. When there's a change in momentum, impulse also has taken place. So the first formula for impulse is simply I is equal to F and T. And the unit for impulse is Newton second. Newton second. So whenever we calculate or we solve a problem and we arrive at an answer, the unit we attach to our answer is Newton second. How is Newton second? How did we get Newton second? It is simply that force is measured in Newton and time is measured in second. And we merge those two together and we have Newton seconds. So that's the unit. Another formula for impulse is simply change in momentum. So if you are told to define impulse, you can say impulse is the product of force and the time taken to bring about change in momentum, or impulse is simply a change in momentum due to an applied force. So remember that in our previous class, our previous video, we said that momentum is mass and velocity, product of mass and velocity. So whether final velocity or initial velocity, it is still momentum. Whether final velocity or initial velocity, it is still momentum. So far as that velocity has mass attached to it, it is still momentum. So whenever there is a change in momentum, impulse has taken place. So another formula for impulse is simply that I is equal to mv minus mu. So which is I is equal to, we factor out m, open bracket, v minus u, which is final velocity minus final momentum minus initial momentum. That is the change in momentum. Final momentum minus initial momentum. We factor out m, we have final velocity minus initial velocity. How did this formula come about? I have a body with a mass m, and this body is at a particular velocity u, and a force acted on this body. And because of this force, this body changes position to assume another velocity v, same body. At this point, this body has a momentum. The momentum of this body is the mass of this body times the initial velocity that the body has, which is mu. While after the force has acted on the body and the body has succeeded in changing position, it assumes another velocity. The momentum of this body at this point now is mv. So let's call this point A, point B. Because of force, this body changes position from point A to point B. Has a momentum here, mu, has another momentum here, mv. So the impulse is simply mv minus mu, which is final momentum minus initial momentum, and then factor out mv minus u is impulse. The unit of this is also Newton seconds. So we have two major formulas for impulse. Two major formulas for impulse. First formula is I is equal to Ft. Second formula is equal to m bracket v minus u, which is change in momentum. So we look at a very simple problem and solve it. So this problem says, example, a force of 20 Newton acting on a body of mass 2 kilograms moving with a velocity of 6 meters per second increases the velocity to 8 meters per second in 0.2 seconds. First of all, calculate the magnitude of the impulse. So this is a very typical question. A force of 20 Newton. What do we have from this question? Solution. We have a force of 20 Newton. They say that force is acting on a body of mass 2 kilograms. A force of 20 Newton acting on a body of mass 2 kilograms. So the mass of the body is 2 kilograms. And that body is moving with a velocity of 6 initial velocity, 6 meters per second, which is the first velocity with which that body is moving before the force acted on the body, and then increases the velocity to 8 meters per second. So 8 meters per second. Let's say calculate, 8 meters per second in 2 seconds time t 0.2 seconds. So the question is saying, calculate the magnitude of the impulse. That body is already moving with a velocity, and then a force acted on the body to increase the velocity. Now we are asked to calculate the impulse. The impulse. They can also say calculate the change in momentum. It's the same thing as calculating the impulse. So how do we do that? We already know that impulse I is equal to Ft. So what's F from our question? F is 20. So I say impulse is equal to 20 multiplied by what's T in this question? 0.2. 0.2. So our answer is simply 4 Newton. 0.2 minus 20 will give us 4 Newton. So there are two methods with which you can solve this. Like we rightly stated that impulse has two formulas. This is the first formula, and we solved it with this method. If we should solve with the second method, we should be able to arrive at the same answer. So what's the second formula for impulse? We know that impulse is equal to I m open bracket v minus u, which is change in momentum. So I is equal to our mass is here 2 kilograms. Our final velocity is of course 8 meters per second, and our initial velocity is of course 6 meters per second. So we have impulse is equal to board mass. We deal with the bracket first before 2. So 8 minus 6, we have 2. So impulse is 2 times 2 will give us 4. 4 Newton second, 4 Newton second. So you see, using the two different formulas, we're arriving at the same answer for the impulse. So product of force and the time taken to bring about change in momentum, and here impulse as change in momentum, all giving the same answer. So this is just a simple basic problem. I'm going to drop one problem for the viewers and people that are following this class to solve it, and keep your answer for me at the comment section. This is an assignment. A ball of mass 5.0 kilogram hits a smooth vertical wall. Normally with a speed of 2 meters per second. Full stop. Determine the magnitude of the resulting impulse. So let me read it out in case you are unable to get it from the board. A ball of mass 5.0 kilogram hits a smooth vertical wall normally with a speed of 2 meters per second. Determine the magnitude of the resulting impulse. I'd like to see your answers at the comment section. Thank you for following. I hope you are able to learn one or two from this class. Thank you. See you again in our next video.